Let's talk about something people are starting to notice with Adelaide's O-Bahn. Multiple buses have now came off the track at the same interchange, all within a relatively short period of time. So how does one of the most advanced guided bus systems in the world keep failing at the same spot? And more importantly, why here? Before we go any further, this does not mean the O-Bahn is unsafe, and this is not blaming drivers. What I'm doing here is looking at design, mechanics, and geometry, because even precision systems have weak points. And even if you've never heard of the O-Bahn before, this applies to any guided transport system. This is one of the incidents involving a Scania K320 rigid. And this is another, the same model but articulated. There are only 2 publicly available videos, but there have been more than 2 incidents at this same entrance. So the question isn't, are buses dangerous? The question is, why this entrance? And why recently within the past 3 or so years? The O-Bahn was made in the 1980s, and this was never as frequent. To understand that, we need to understand how the O-Bahn actually works. This is an O-Bahn guide wheel. Every O-Bahn bus has 2 of them, one on each side. They don't automatically steer the bus, instead they physically constrain it, keeping the bus aligned on the concrete track. The driver still controls the steering wheel during normal road driving, but once the guide wheels are engaged on the O-Bahn, the bus is mechanically guided. But how does the bus get onto the track in the first place? This is the steel funneling used at O-Bahn entrances. The idea is simple. The bus must contact the right-hand curb first, allowing the guide wheels to be smoothly guided onto the rails. But here's where things get interesting. The right-hand funnel is straight, aligned with the concrete track. The left-hand funnel is angled inward. That difference matters a lot. If a bus approaches slightly misaligned or too fast, the guide wheel doesn't slide neatly into place. Instead, it hits the angled funnel sideways. At that point, the force isn't being absorbed gradually, it's being applied laterally, directly into the steel structure. That creates extremely high stress in a very short amount of time. So what happens if the bus hits this left funnel too hard? That. But there's something else people noticed. The first crash shows the steel funneling breaking off. In the other one of the incidents, the bus didn't even appear to strike the funnel at all. And in another, the bus fell inside the track rather than outside of it. So why did the funneling still fail? These bolts are designed to fail. They're called shear bolts, and you see them everywhere in infrastructure. Their job is to break before something worse does. So yes, if a bus hits the funnel too hard, the funneling can break away, and that is intentional. It prevents damage to the bus frame, the steering system, and most importantly, the passengers. Now let's talk about speed. The O-Bahn entry speed is 40 kilometers an hour, but many buses exit or enter at 45 to 50 kilometers an hour. They aren't supposed to, but if they drive the bus on the tracks properly, nothing would happen. If a bus was suddenly forced sideways at that speed from the funneling, passengers would be thrown across the cabin. Braking the funneling is actually the safer failure mode. There's another safety feature most people don't notice. The guide wheel sticks out roughly 100 millimeters from the side of the bus. If it hits something solid at speed, a pole, debris, or infrastructure, it's designed to break away. That's because a guide wheel failing is safer than the entire steering system breaking or tearing free. The goal is always the same: protect the bus and everyone inside it. However, there is a downside. If the funneling does not break or the guide wheel disengages at the wrong moment, the bus can jump completely off the right side funneling. And what's on the other side of the track? Another bus, travelling in the opposite direction. In the best case scenario, both tracks are blocked and the bus coming in the opposite direction stops. In the worst case scenario, it's a head-on collision. And unlike a road, the bus, still on the track, can't swerve. So now we understand how it happens, but we still haven't answered the most important question. Why does this keep happening at Klemzig? First, Klemzig is not centered like other O-Bahn interchanges. At most interchanges, if a driver is slightly misaligned, the bus tends to contact the right-hand tunnel first. Or if it does hit the left funnel, it's not very aggressive, which corrects the path, or they wouldn't have to turn to enter the tracks much in the first place. At Klemzig, if the steering input isn't perfect, the bus is far more likely to fall away from the track entirely. But there's another issue. The Klemzig entry is unusually long. That means drivers must begin their turn later and then hold that steering angle longer than at other entrances. That's a subtle difference, but in a precision system, subtle differences matter. I believe that combination, caused by the offset alignment and the extended entry length, is why this entrance keeps appearing in incidents. It's not reckless driving, it's not an unsafe system, it's a bad design. And just to be clear, the O-Bahn remains an extremely safe transport system, but like any guided busway, the most critical moments are entry and exit. That's where precision matters most. So how do we fix it? Simple. Extend the funneling here so the buses enter the funneling before the bend, making the drivers not needing to turn the bus. So what do you think? Have you noticed this or experienced it yourself on an Adelaide Metro bus? I'll see you in the next video.